When you are setting up a lab and a lab that deals with human specimens, the ability to do things and get the same results again and again and again really matters. And a lot of research laboratories don't recognize how important that is. What got me interested in science? I guess I was always interested as a student in school. My dad was an engineer, but I had uncles who were in engineering, in medicine, an aunt who was a psychologist. So I think that kind of interest in science, in biology, was always there. I enjoy history and geography. My mom is a history teacher, but that was, part of living, growing up, being part of society. The science part of it was a little bit more challenging, so that was really what I really enjoyed. Learning new things, and particularly in biology, the fact that you can figure out how things work. Yeah, I think it was a kind of progression. So from medicine, I did medicine as an undergraduate, and I was trying to figure out what to do after medicine. And I liked the idea of psychiatry, I liked the idea of ophthalmology, and I liked infectious diseases. So I went and spent a year in Delhi working at the RP Center for Ophthalmic Sciences. And basically, my family has a familial tremor. And I was living with my parents again after a long time and realized with lots of family coming to visit that many men, many women in our family had that tremor, and it got worse as people got older. So I thought, okay, a field that requires really fine surgery is probably not the best investment to make at the moment. So then it was really around psychiatry and infectious diseases, and I finally wound up doing microbiology because that was the closest thing to infectious diseases at the time. There was a book that was written by Paul de Cruyff in the 1930s, which is called Microbe Hunters. And then there were TV series called Medical Detectives, most of which were around infectious and metabolic diseases. And I love the idea of finding a problem and then looking for a solution to that problem. But the problem in microbiology in hospital was really the fact that you were only a part of the solution. You didn't get to look at the whole picture. So, unlike what I found in the UK subsequently, where the UK clinical microbiologist is a clinical microbiologist, they see the patients, they advise on the patient, they decide on the treatment, they get to see the outcome. In the Indian system, it was here's a sample, figure out what's in it. And that kind of partial picture wasn't really enough for me. So when I finished my training and I was offered a job in a research department, I said, okay, here is where I can get to ask the questions and decide how I want to work. So I moved into a research department, and by then I had my MD. So within the medical system, you don't really need a PhD, but I decided that I wanted to do a PhD because it's a different process. Even in an MD, you have a dissertation, but that dissertation is usually something that has been assigned to you, whereas in a PhD, you get to develop the direction of what you want to approach and how. So I think I'm a bad example for that, right? And the reason for that is because the institution that I've been in for most of my career was started by a woman, was developed for women, basically to train doctors. In 1918, she started a program to train women doctors. And it was only in 1947 that the first men started to be admitted into the medical college. So, this is an institution and an atmosphere that traditionally has had more room for women than most other places. So, if you look here at the medical college and you look outside at science institutions, what you see is really excellent representation of girls coming into college. The problem is that the higher up you go, the fewer and fewer and fewer women there are. And the reasons for that are complicated and many. You do have this expectation that you will be the one looking after the children. You have this expectation that if anyone is going to take a gap in their careers, it's going to be you, right? You have this expectation that you will be home at a certain time. You have this expectation that you will not travel until everybody has agreed that you can travel. And it sounds like a favor. And for me, I was very, very, very conditioned. I was born in the 60s. I grew up in the 70s and 80s. So by the time it came to starting my career in the 1990s, I was very conditioned into, even though my mother had worked her entire life, my parents had this expectation that my sister and I would be working lifelong. It was you will be working lifelong and you need to manage your house and the children and everything else. So while it was a very supportive family environment, the societal expectations had not changed. So the vaccine production capability is down to the companies. So this is not about the labs, the actual production component. And we have some companies that have the ability to do world class production. What we didn't have, and what I realized really, when you are setting up a lab, and a lab that deals with human specimens, the ability to do things and get the same results again and again and again really matters. And a lot of research laboratories don't recognize how important that is. When you're doing exploratory research, you do the same experiment 3 times, get very similar results. That gives you enough numbers to be able to say that here's the range and this is what I found, right? But when you think of the heterogeneity of humans and of the kinds of results that you see in humans, the spectrum of people that we have, their clinical symptoms, the frequency of infections, and then the heterogeneity in the samples that come from those people, then the measurements that you need to have need to be very, very, very tightly controlled. And most research laboratories don't recognize that. So when I started to work with vaccine companies, which is now about 15 years ago, it was built on the fact that we had been doing all these field studies and standardizing complicated assays for human specimens. And then doing this for a regulatory purpose takes it up a notch. And I found that my lab was the only one doing that in all of India. So it turns out that we were one of 2 labs in the whole world that could support rotavirus vaccines. We learned from the lab in Cincinnati and replicated that in India. But there are only 2 labs in the whole world doing this for rotavirus vaccines. Okay. So then I looked around and figured out that for most new vaccines, you really need this. And this is a unique contribution that we can do, whether it is tightly controlled animal models or tightly controlled laboratory assays, or outstandingly well done clinical studies. All of these are essential for the companies to do their job, right? So that is the translational. You also have this other missing piece of Indian scientists. You've got great structural biologists, you've got great protein chemists, you don't have great human immunologists, and you really don't work on infectious diseases with the point of view that I'm going to make a vaccine, because making a vaccine is application. That is something that people do if they are not good basic scientists trying to figure out molecular mechanism of why this particular pathway is stimulated and what it results in. But I think you need both basic research and application. What I've seen actually with the SARS-CoV-2 pandemic is that all these basic labs that turned up their noses at poor medical people are now suddenly getting very excited about the idea of, oh, we can make a difference. Whether you look at INSACOG, which is doing genomic sequencing and trying to figure out where your next variant is coming from, or labs that have set up to do high throughput PCRs, or labs that have started to do neutralization assays, all of them are finding that there is a huge role for them in diagnostics, in screening for drugs, in the evaluation of vaccines. Maybe it was our problem from a medical field because infectious diseases were not glamorous, right? Neuroscience is glamorous, cancer is glamorous, right? But infectious diseases, that is a solved problem. Now I think people are seeing that nothing is really a solved problem. And the tools that basic scientists have can be applied across a range of problems. And if they decide that they want to do applied science, they have the ability to think about things, to think about approaches, to be able to develop approaches that we can take. So for example, new diagnostics. I mean, the fact that IGIB used CRISPR-Cas to develop Feluda, right? Lots of opportunity. This pandemic has been very unpredictable. But I also think that in many ways we've been very, very lucky that this has not been the killer virus, right? It could be way worse than it was. Now, just imagine if instead of what we got as the ancestral variant, so you have the Wuhan virus becomes the D614G, that spreads more easily. You have 8 months of that, and then you get the alpha variant. You have 2-3 months of that, and then you get the delta variant. Suppose we had started with something as transmissible as the delta variant from the get-go, right? That would have been a disaster. What we actually saw was we saw a virus that we could reasonably handle. Even with delta, it can be worse, but there is a huge difference between an R naught of 2.5 and an R naught of 6.5, which is what delta has, right? So, in a sense, we've been just so lucky that we did not wind up with that jump to humans, spread to humans happening with a virus that was way more transmissible than it was. We've been incredibly lucky that this is a coronavirus where we knew a lot about the spike protein. We had people who had been working on vaccines for SARS and MERS and were able to transition that. We've been incredibly lucky that mRNA vaccines worked, that vectored vaccines work, that it's actually a virus with a single protein where you can do a lot. Yes, can you do better? Yeah, sure, we can do that. But that is at a different stage. But if you wanted a rapid, immediate solution, what's easier than a virus? If you block one protein, you're done. You've got pretty good protection across four people. So I think that was lucky. In India, what did we do? So when the pandemic started, by February, I was, doing all these talks and various people saying, disaster coming, do something about it. Disaster coming, do something about it. Not disaster coming, but virus pandemic coming, do something about it. And nobody was hearing a thing. Everyone thought it was a cute talk. Okay. So I was actually glad when finally we had the lockdown because, from the beginning of March, the cases had started to climb. And I kept waiting to see a response, and the response wasn't happening. So I was glad when the lockdown was announced because I thought, okay, this is reset button. We are actually going to do something now. It turned out the lockdown was such an intense lockdown that there was no opportunity to do anything because I was director of THSTI at the time and I was trying to establish a cohort. I was trying to build the labs, get the assays, get the BSL-3, import the virus, get it from NIV, get it from somewhere else. And there were no flights. So there was no way of doing anything. Ultimately, it turned out that all the resources that we actually built with help outside the country instead of inside the country, which was sad because the silos were created and the silos lasted for a really long time. They're still there to some extent. In that sense, if the lockdown was intended to suppress transmission, I think we locked down too early. If it had been a lockdown for preparation, it would have been great, but it needed to be designed for preparation, which it wasn't. So as soon as it was lifted, cases started going up. I still don't quite understand why the first wave went down as quickly as it did. I would have expected to see more of a flare up around Diwali because the second wave was, it peaked in September and then came down. And I don't still understand why that was. I thought it would be because of higher exposures, lots of asymptomatic infections and lots of exposure. But the sero surveys did not show that. At least the ICMR sero surveys didn't show that. The local sero survey were showing explanations for why disease patterns had changed. But there was a discrepancy between what they had and the ICMR sero survey. In the second wave, I think if we think about it, what we should do is take a look at the difference between North and South and what happened there. The North collapsed, the South didn't. And the North collapsed because in the North, health systems are weak. The spread of infection is determined by how people interact with people. So that can be a public health problem. It can be what the government made it, at least initially, was a law and order problem. There were some of my research staff that were being beaten up by the police for collecting samples. And it's just nuts, but then you don't teach the police what is right and what is wrong. So they treat it as I have gotten an order and I need to keep people in their place. So there is that infection piece, and then there is the hospitalizations and deaths piece. The infections piece affected everybody in the country because it's all about interactions. But the hospitalizations and deaths and how people did, I think the difference is how strong are your health systems. And in the South, we suffered a lot less because our health systems were generally strong. In general, I think the government response could have been better. Everybody tries. Nobody wants people to get sick and die, right? Nobody is callous about these things. But you need a deeper understanding of how to do public health interventions. And in our very hierarchical, very stratified society, we firmly believe that top down is how decisions should be made and implemented. Whereas this is a problem that requires involvement and local solutions. So I've been dealing with vaccine misinformation, disinformation, anti-vaxxers for a really long time. And I think there are some people who do it deliberately. Either they have such firmly held beliefs that you're never going to change their mind, others are trying to provoke something, right? And I don't understand why you would want to provoke a response that results in damage to society, because it clearly does. But those are people who have a pattern of behavior. Every vaccine is bad, every this is going to do you damage, etc. So those people you can't do anything with. But there are many people who've been convinced by the communications that they have had from a range of different sources that there's something going on that they don't trust, or that there is potential for harm. And for them, by and large, if you listen to them and you try to understand how they got the conceptualization that they have, and sit with them and ask them, can I present what I think is the situation? It's about respect. It's about hearing people. It's about respecting people. And then it's about conveying the information that you have without saying, now buy into what I'm telling you. Now change your behavior because of what I'm telling you. I think as scientists, we may feel very informed, but we arrived at that through a process, and other people will need their processes. I think everybody can apply the same principles that scientists learn to do over time, because it's not anything exceptional, it's common sense, right? It's about the ability to integrate information. It's the ability to place it in context. Everybody can do that. So a lot of my work is done in the community, dealing with mainly mothers and children, and we work in urban slums because that's where the bulk of the problems are. And to me, I think the fact that you think you need to, so all my field staff are told, you will treat people with respect. They are doing you a favor by participating in your studies. They are partners in the process. This whole thing that we have in clinical research of subjects is a problem to me. Similarly, with the government, everybody is a beneficiary. I'm sorry, but that's your job, right? For me, if I'm doing research and you are a volunteer in the study, you're participating in the research as much as I am. So I think that approach to working with people is something that is essential. And I don't think that society is divorced from science. It's a problem of communication. So the first one is we tend, and particularly as women and frequently as Indians, to not recognize what we are capable of. Okay? So we undervalue ourselves and our achievements. And I think it's important to recognize that if you do reasonably well in India, you'll do brilliantly well in other parts of the world. Our competition is so intense that, if you've been successful in India, there's no competition in the rest of the world. Okay? So that's one thing. And the second relates to that, which is we tend to tell ourselves not to bite off more than we can chew, right? Do something that can be done within this funding, this time period. Ambition is not a good thing. I mean, big problem solving ambition is not a good thing. But I think that you have to hold that big problem in front of you. You may not be able to solve it. And if you're doing your PhD or something, Unlikely that you'll solve the entire big problem, but you can take a component of it and make significant progress towards that. But trying to address big problems, I think, is something again that we don't do sufficiently. And sometimes it's not possible to solve a big problem on your own. You need to link up with others who have different kinds of expertise. You need to approach the problem in many different ways over long periods of time. You are bound to fail. And if you're not failing, obviously your problem is not big enough, right? I think the idea of holding that big problem in view, it doesn't matter what the field is, you have to be able to be ambitious about what it is possible to do. So, you remember in school we used to get these report cards that said, can do better? That's it.